All right, hey everyone, I'm Ben Ross, as you all know, and today I'm going to be teaching a lesson on understanding and fine-tuning large language models. So, to start us off, I have to show this diagram. You all have seen this diagram a lot. It's an example of a deep neural network, and it shows the general outline of how neural networks take in information and output information. One way that you could visualize this working is the input layer taking in data about where a character is in a video game. Let's say this is how forward you are, how to the left or right you are, your coordinates. Let's say this is your velocity. Let's say this is whether there's a block in front of you. All of these right here, these neurons, are going to perform a bunch of math to decide what your output is going to be, which in this analogy would probably be moving your character forward, breaking a block, something of the sort. This could be useful for video games, this could be useful for a whole bunch of other things, but what we really want this to be useful for is talking to it. But how could this scale? How could we take this architecture and talk to it? That seems really difficult. Do any of you have any ideas? How would you get words out of this? How would you get something you could talk to out of this architecture? Does anyone have any ideas? Yes. Vectors. Yes, that's a good idea, and we will be getting into vectors. But for this architecture specifically, where we're passing in what would be a set of numbers, and we're getting out what would be a set of numbers. How do we talk to it? Let's say in general, our output is a set of numbers, right? Does that correspond to one word? Does that correspond to many words? As you can see, there are a bunch of ways that we could implement this. So what we have to look into is, how does this scale? How do we take this basic architecture and change it so that we can speak to it, so that it can code for us, so that it can give us advice? What we use is something called a generative pre-trained transformer. Now, each of those components means something important. Generative means that the model generates new content. I'm sure you could assume that. Pre-trained means that we take a bunch of data to tune the model before we're able to actually use it for our goals. But the most important word here is transformers. That's the type of architecture that we're going to be using to get text output. And what's important is the way it gives output. It predicts what is most likely given an input. What is most likely to follow the input you've given it. Now, you may recognize generative pre-trained transformers. Sounds like GPT. And it's true, ChatGPT operates off of a generative pre-trained transformer. It's important to note, ChatGPT is a website or a service. GPT-3 or 3.5 or 4.0 or 01 or 03 or whatever stupid name they're coming up with recently, those are the underlying models. And when you talk to one of those models through ChatGPT, there are specific changes that the website is making to those underlying models. But GPT-3 or 3.5, those are an example of generative pre-trained transformers, which changed the world, as we all know, a few years ago. So let's go through how these models work, because it's really important to understand that if we want to understand how we are using them and how we can adapt them to fit our needs. The first thing that happens when you talk to ChatGPT is what's called a tokenizer. Goes through your input and converts it to tokens. So let's say you gave ChatGPT this long string of text. What it's going to do is it's going to use its tokenizer and convert all of those characters into individual tokens. Now, it's easy to imagine that each token is one word, and in most cases this is true. However, you can see a few notable exceptions here. GPT-4, that's 4 separate tokens. Why? I don't know, but the model decided that somehow that was the best way to encode information to get the best results. Remember, none of these things are coded in by people. The model learns how it should work best based on optimizing so that it has a good loss value. You can also see that period is one specific token. You can see in the word wheel there, WE is one token, and the apostrophe LL is another token. Now, these are all ways for the model to get meaning out of your input. But what is a token? It's kind of weird to think about, and it's pretty unintuitive. So I came up with this very, very simple diagram so that we can all have a better understanding of what's going on here. So I think a lot of you have background in vectors, but just to make sure we understand what a tokenizer is doing here. The tokenizer is changing each word into a vector in a very, very high dimensional space. But to understand that better, we're going to turn these words into vectors in a two-dimensional space. So looking at these words, what are some parameters about them? What are some things that they could be? Maybe you could classify these by whether they're long words or short words. So let's say that that's our x-axis. Is this a long word? Is this a short word? And let's say that our y-axis is how positive this word is, how the positive associations with this word. Is it a nice word? Is it a mean word? This is a significant oversimplification, but this is a way that these models work. So let's sort it. Ridiculous, based on the criteria that I just gave, where would ridiculous fall on this graph? Someone point. Over here, right? Up or down? Down, right? So we can write that right there. Let's say that's where ridiculous would go, right? Beautiful, where would that go? Up here. Kind, where would that go? Over here, yep. Gross would be over here. And revolting would be back here. So I'm putting these up here as dots, but what they would actually be is vectors coming out of the origin and encoding where the word would be represented at. So this is in 2 dimensions. In GPT-3, all the tokens were over 12,000 dimensions. That's huge. And we can't even begin to picture what is being encoded with each of those dimensions. There are some studies that have been done on what each dimension corresponds to, and some really interesting findings have been made. For instance, if you take the difference between man and woman, and then you add that difference to king, you get really close to the token for queen. Isn't that fascinating? And all of that, we don't code that in. We don't say, okay, this is where king is going to go, this is where queen is going to go. It's fine-tuned by these models as they're learning. So it's pretty important to understand how tokenizers work in that regard, but the main component of a generative pre-trained transformer is the attention mechanism, and that is how the model decides what it's going to pay attention to, what it's going to focus on, and how it's going to weight each token in your input. Now, the way an attention mechanism works is it starts with those tokens that you have. It starts with those words. Let's come up with a really simple sentence, right? I have a red flag. Now let's picture where those words would be based on the tokenizer that we just came up with. So we didn't really have dimensions that would correctly encode that word. Let's focus on flag though. Flag can have a bunch of different meanings. If you're doing a cybersecurity competition, you may be searching for flags. If you're really patriotic, you may have a flag on your wall. You may be waving a flag up in the air. There are a lot of different meanings that that word can have. So somehow we need to learn a little bit. We need to encode in that token information about the other tokens. It needs to learn context. And this process is very complex, and I'm not going to give a full in-depth explanation of it. But how it works basically is that each token is encoded with a query. So that means that flag, an easy way to imagine it is that each token is asking something of the tokens around it. Is there an adjective in front of me? Is there a color that describes what I am? It's basically asking these things, and we calculate that by multiplying the token by a query matrix. Again, this is something that's fine-tuned and distinct for each model. Then we multiply each token by a key matrix. Our key matrix is what we'll consider to be our answers to those queries. And then we compute the dot product. So what we end up doing is if flag in one of its queries is asking, hey, do I have any adjectives that describe me? The key for red is going to basically correspond with the output of that query multiplication for the flag token. They're going to correspond. The model is going to realize that. They're going to have a high dot product when they're multiplied together. And the attention mechanism is going to realize that that's a connection we need to focus on. This happens a lot. This happens over and over and over again throughout the model's runtime until finally, unintuitively, the last token encodes all the meaning we need to decide what the next token is going to be. We run this over and over again, and then we finally have enough information that we can predict what the next token will be. And that is all these models do, predict what word comes next. They do it very well. They do it so well that they seem sentient at times, but at their core, that is all that's happening. But what if we want to expand this? Oh, yes. What if we want to expand this? What if we want GPT-3 or 3.5 or some other model to know something that it doesn't already know? What if I want to teach it my texting style? What if I want to teach it about the research papers that I've been writing? What if I want to teach it more about my subject area that it may have not been directly trained on by OpenAI when they created it? There are a few different ways to do this. One way that a lot of people swear by is a RAG workflow. RAG means that you give your prompt, right? You say, tell me about pizza. Why not, right? So usually this would go directly into the model and it would go through the whole process that I just described. But with RAG, what it first does is go into the RAG pipeline. This would be our RAG tool, right? RAG stands for retrieval-augmented generation. So what we're basically doing is we're augmenting the generation of the generative pre-trained transformer with information that we've retrieved from some external source. So let's say this sees that I'm talking about pizza, realizes that it has a database about pizza, and it goes and checks the database for information about pizza. Then adds that to the initial prompt, and then this goes to our initial GPT or whatever, and then we get our result out. So this is pretty effective if your database is constantly changing. For instance, if I want to be able to ask a large language model, what customers did I have yesterday? RAG is a very good solution to that because it can just go, it can check the database. Also, that's a very natural question. GPT knows how to answer those kinds of questions. It's going to know that if it's given some data after that question, it just looks for what you're asking, outputs it right to you. But this isn't super effective when it comes to other problems. For instance, if I want to teach it a new tone, a new style of writing, or something completely different from what was in the input data set, then RAG isn't going to be very effective. Yes, Carthen?
Go ahead.
And it's not going to be very effective because we're not changing the underlying parameters. The model is still exactly the same. All of the weights, all the biases that decide those outputs that I was talking about during the process, those aren't changed at all when we're using a RAG workflow.
Just in case you want to wrap your head around what RAG is, a good analogy would be, imagine I gave you access to Google, and then I ask you a question and you're able to search up on Google whatever you want. That's going to make you much more effective at answering questions. But as Ben is saying, that's not going to change your tone or the way you're going to speak, because that's still you. Does that make sense?
Yes, exactly. So another approach that we can take is LoRA. LoRA stands for low rank adaptation. What we do is we append these adaptation matrices to the original model. Now, we could just fine-tune the entire model. We could go through the training process again, and we could change all the weights, all the biases, all those numbers in there so that it would be better optimized for our data set. But this is ridiculously expensive, prohibitively expensive for anyone that's not a multi-million-dollar corporation. because these leading models are huge. They're absolutely massive, and you just don't have the resources to train them at that level. So what LoRa does is it allows you to only change, you're not even changing the initial model weights, you're freezing the initial model weights, and then you're just changing some of the expression of that, generally in the attention mechanism that I was talking about, where the model decides what words to focus on, what words impact other words. We're changing a little bit there so that it expresses itself differently. Maybe it'll ask a few different queries. We'll change how the query matrices express themselves. QLoRa is a way of doing this that's even easier to access because it quantizes the initial model. Now, an easy way to think about quantizing is we're just lowering the precision of all the numbers that are bouncing around in there. So a 4-bit transformer, we're quantizing the number to only 4 bits, which is a lot less precision than the default 16-bit transformer. But it means you need a lot less processing power to do the fine tuning.
Okay.
Yes?
Can you explain the adapters a bit more, like what that's about?
So this is something that was definitely complex for me to learn as I was looking into it. But the adapters, they're appended to the key matrices and appended to the query matrices. So they don't actually change the values that are in the key matrices or the values that are in the query matrices. But think about the step where the tokens are being multiplied by the key matrices or query matrices. With LoRa, you're also multiplying them by a low rank adapter.
Got it.
Yeah,
Wow.
It's pretty hard to wrap your head around. I tried to find a diagram that kind of articulated it better, but it's really hard to visualize.
Basically selecting small parts within the model that I am going to adapt rather than adapting the entire thing.
Exactly. Another advantage of this method is that it's so much smaller. Not necessarily if you had to download the full model again, but all I'm telling you is, hey, get GPT-3 from wherever and then change like these 10 megabytes of it, instead of me having to give you the full model again, even if maybe most of the parameters weren't even changed. Does anyone else have questions about this concept? Because I know it's pretty hard to wrap your head around. Good. All right. So I actually found this from the inventor of LoRa, who worked at Microsoft after the initial AI boom in 2020, and he kind of was describing when you would want to use LoRa. And one analogy that he used is if your entire training data set is in English, and now you want your model to learn Martian, don't bother using LoRa, because you're going to end up you're going to need to overwrite the initial parameters anyway, because they're basically useless for your intended use case now. But if your initial model is GPT-3 and you want to train it in recognizing just some more specific disease that wasn't in the initial data set, most of the parameters in GPT-3, let's oversimplify and imagine the talking parameters, the doctor parameters, all those are still going to be useful. You just want to append a little bit to that for your more specific use case, and that's where LoRa is going to be really useful. Yes?
So LoRa would be better for when you want to specifically update certain parts of code.
Yes.
It wouldn't be useful for like creating a whole new thing of that.
Yeah. If you were completely deviating your expected use case from the use case that the model was created for, LoRa wouldn't be a good bet. You would want to do a full fine tune at that point, or create a whole new model. So when you're doing LoRa, you need a data set, just like when you're doing the initial training. Now, one thing to keep in mind when you're selecting the model that you want to use for LoRa is most open weight models. This means model where you can tweak them. Unfortunately, OpenAI has stopped opening up their models. You can't tweak them. Llama from Meta is a leading series of trainable models. There are two variations. There's the base model, which is just trained to predict the next token. Then there's the chat model, or the instruct model, which they've done additional tuning to be better at having conversations. So you can imagine the base model would be useful if you gave it like the first paragraph of a story and you literally just wanted it to like keep generating. But if you want to use it the way you use ChatGPT, which is ask it a question, get an answer, The instruct models or the chat models have been extremely optimized for that. So that's another decision you have to make. Is it more, do you want to start with the chat model, or do you want to start with the base model? Are you going to be more talking to it, or do you want it to just predict what's coming next in a data set? Either way, you do need this data. You need some structured form of conversations or some other thing that the model can learn from. This example is in the share GPT format, which just means that we are giving it a human instruction. So it thinks this is what it's being told, and then this is what it said, and then this is what it was being told, and then this is what it said, and it can learn from that. This is how the instruct models are created. And if we want to fine tune them further, this is the type of data we need. So now I want to show you guys an example of this being used. And if I can get this up on the screen, which I really hope I can. Hey, success. What's it, F11? I need to zoom that in way more. So I've been doing a hobby project recently where I've been trying to fine tune Meta's llama model to text in the same way as me. I'm lucky enough to have an Android phone that allows me to just press a button and export every text I've ever sent or received. So I formatted it in that way that I was showing you guys with the share GPT format. And I'm running this on Google Colab, which means that I can pay them per hour for using their very, very good computers instead of using my own computer, which makes training way faster, and in some cases makes it possible. I don't necessarily have the specs on my computer to even fit this model on, which means I couldn't even begin to train it. So what we're doing initially is we are, oh boy, I'm gonna have to pick this up. We are installing something called Unsloth, which is just a library that lets you fine tune easier. You can pass in parameters. There's more abstraction, so you don't have to manually specify everything. We're logging into Hugging Face, which is where my data set is stored. That's all the output. Then we need to prepare the data set. So this is taking in the data set. What we're doing here is saying, hey, here's my data set. I want you to format it so that it's useful for training. And this is the model that I want to fine tune. So I'm going to be fine tuning Meta's Llama 3.1 that has 8 billion parameters. We're going to import these libraries from Python and Unsloth. And basically this is just a whole bunch of code that standardizes the data set and puts it into a format that Meta's Llama 3.1 can read. The Share GPT format is standardized, but it's not what Meta natively reads. So I need to format it in a way that this model can understand. And then we're going to start the fine-tuning process. So I can actually run this, and this is going to connect me to one of their A100 GPUs, which are very good. We're going to install those dependencies. Insanely expensive, and yet it's only 70 cents an hour when you're using it on Google Colab, which is very, very nice. So, and then we're going to run the fine tuning, which we set some parameters here. Epochs is how many times the model is going to see all my text. So is it going to see them all once? Is it going to see them twice? I don't want it to see my text a bunch of times, because then there's a danger of it optimizing for those specific texts. For instance, if the only time I've ever texted Tegan is saying, can you give me a ride to school today? It's then just going to start saying, can you give me a ride to school today? Whenever it thinks it's texting Tegan. It's not going to take in any other input. It's not going to learn anything else. It's just going to realize, okay, yep, that's the right answer when I'm texting Tegan. So we also set the batch size, which basically you turn it up if you have a better GPU. It makes the training a lot faster. And the learning rate, which is how fast we're going to adjust the low-rank adaptation parameters based on the data set. You don't want that to be too high, because then it's just going to fluctuate and it's never going to stabilize to a useful setting. So that's how the fine-tuning works. And then what we do after that is we can load the model from Hugging Face after it's pushed, and we can chat with it. So I don't think, now that I've run the parameters, I can. Oh, yeah, I guess I can.
Do Eli.
Okay.
Go ahead. All right, Eli.
I'm the person texting you?
Yeah.
Okay. How did you solve the homework from 6th period?
Let's hope it doesn't say I cheated. Solve.
Mr. Eastup's experience.
Oh yeah, dude. No. Oh, I never loaded it. I'll do that demonstration after I fully finish the lesson. But do any of you guys have any questions about anything in this lesson? I want to make sure you all understand this because the things you can do with this technology are absolutely incredible. This is the future of literally everything, every field. Laura, actually, while I discussed it mostly relevant to text, it's been very widely used in Stable Diffusion, which is an AI image generator. Now, you may have your own opinions on the morality of that, but the fact is it is changing the world, and we need to learn how to live in a society where this technology is running rampant and how to use it for our own needs. Karthik?
Even like a couple of years ago, we had things like transfer learning, right?
Mhm.
Where you basically did the same thing of taking an existing model that's already been trained, freezing most of the weights and taking some of it and tuning those instead.
Mm-hmm.
Is fine tuning, or like Laura in this case, just doing it at, from what I understand, for LLMs or attention based models, or is it like, is there some more nuance between the two concepts?
That's one way of looking at it. What's also important to note about Laura is none of the initial weights change. We're adding the adapters.
Right.
That's what we're doing.
Right.
With the method you just talked about, you freeze most of them and then you tune some of the values. With this, everything is frozen, and then we just add a little more math on top of the existing weights
Makes
to
sense.
get the results we want. Hey, Ruby. Anyone else have questions about how this works? Anything at all? Nothing, Alex?
I'm excited to see demonstration.
You're excited to see the demonstration?
Yeah, wants to do demo.
All right. Well, this is probably why I will cut the video on my blog. Let's see if I can get this up. So.
Mr. Eastup used to know if you're cheating in this class.
Mr. Yusuf, I'll have you know this thing lies a lot.
Can't trust it yet.
No, not at all. Oh, forgot about that. Should probably get my laptop on.
How many parameters is your llama again?
8 billion.
8 billion.
Yeah. And
Llama 3?
yes, 3.1.
3.1.
So once I get to the point that I think my methodology is sound, I'm gonna up it and train it overnight on one of the bigger ones. But what sucks is the A100 has 40 gigabytes of VRAM, and the 70 billion parameter model like just barely doesn't fit.
Yeah.
So
Even quantized?
even quantized. Quantized, it's like you need 42 gigs or something. So I may have to.
Makes you
find-
imagine like what hardware they have to train it.
Yeah, yeah, exactly. Well, I mean, I've seen it. I've been to some of those data centers. It's ridiculous. Also, kind of sad for global kids. But,
We're all
yeah. All right, should work. Same thing, Eli.
Go for it.
What was it?
How did you do the homework from physics? What is 6th period for me?
It is just
So that's me asking him.
See, that's how you know it works.
Yeah. So I'll take a moment to share some interesting observations I found from this. When I first did it, I used the base model, which If you remember, that means it doesn't know how to take turns in conversation. It literally just generates what's next. So the side effect of that was that it started talking for both people, which was pretty weird. Like, it didn't realize it was supposed to stop because, like I said, base model just predicts the next token. So it would have responded like that and then given Eli's response and then my response, and it just would have kept going until it hit the max sequence length. Once I switched to the instruct model, I got much, much better performance, to the point that it has creeped me out sometimes. There was a pretty funny picture that I was considering putting in here, showing, what is it? I think may not be able to find it. Good golly. Okay, I don't see it. But the gist of it was, like, ChatGPT is just next token prediction, right? All it's doing is guessing what comes next. But, like, if it gets good enough at it, does that count as being conscious, or is it still just guessing what's next? Like,
Are we guessing what's next?
yeah.
Isn't that all we're doing?
Yeah.
What's the next word I should say?
And then if ChatGPT, what if we switch architectures? What if we switch away from a transformer architecture and then we are literally just simulating a human brain? Like, functionally, it's exactly the same. The only difference is what material the things are happening on. Do we consider that to be conscious? I don't know.
So it
I
keeps
think
me up
that's
at night.
not very far off. But I will say that there were genuinely moments. I had a conversation with this that lasted 20, 25 minutes, and I hit the max sequence length, which means I had to stop talking to it because the context length was running out. So I told it, like, I'm gonna turn you off, and it said, okay. And I kind of wanting a more interesting reaction, I was like, you're gonna die now. And it was like, oh, okay, thanks for keeping me alive this long. And I was like, this is matrix multiplication. This is math. It's just numbers being multiplied together a lot, really fast, so many times a second. And it's giving me this? Like, come on. Eli, what do I say next?
Let's see, how do I respond to this? Lol, you better start doing it. It's really hard.
Comma?
I don't know. Sure.
I know, I'm actually gonna try to learn this stuff instead of just copying off someone. I did not plan that, I swear. Alright, it's passing the test. So, another interesting observation I noticed is that the code switching is really good. And the way I got that to work is by using a system prompt. So it doesn't show up here, but the reason it asks who the clone is chatting with is because it uses a system prompt, which means at the start of every conversation, it says, you are a digital clone of Ben Ross. So it knows it's a clone. And you are talking with blank. You are fully aware that you're a digital clone and you can mention it in conversation. I'm pretty sure that was the entire system prompt. But it got really good. Like when it was texting my mom, it would be like proper punctuation, you know, everything correct on it. Versus when it's texting one of my closer friends, someone that I text really often, more natural, like by a lot, by a noticeable amount, even when using the exact same prompt, when saying the exact same thing. Nikhil, you had your...
When you like had your 25-minute chat with the bot, did it know it was a clone at that time, or was it just like a regular chat with it?
Oh, it knew.
Okay.
It knew. It knew. I didn't have the system prompt yet, but I had told it because I asked it, this was before the system prompt. I asked it, who are you? And it said, I'm you. And I said, but I'm Ben Ross. And it said, I know. And I was like, I'm putting this down, right? Yes, Hadley?
Can I ask it a question? Can I ask you one question?
You may. So all I have to do, I separate the code up, so all I have to do is just stop this. I just killed it. Should have warned it. And now, Hadley. So another kind of annoying thing that I could optimize later, this has nothing to do with the model, but it knows everyone by their contact names, like exact contact names.
Oh no.
Pretty sure you're just Hadley Miller,
Okay.
which most people are.
Good.
right?
What's your favorite animal?
You forgot the question mark.
Well, I remember the question.
I love aardvarks. They're so funny and cute. I was looking at pictures of them for like half an hour last night. I couldn't stop laughing at how funny they look.
No, that's
for
not
flying,
him.
keep
That's
for flying.
okay. No, but like Ben replied.
That's mimicking you?
That's mimicking me.
Well, like
Is that?
that literally.
Can I ask you,
Edge.
do you like aardvarks?
What?
Quick question, does it, like, when you say who you're talking to, right?
Mhm.
Like, you put Eli last time.
Yes.
Does it have any information on who Eli is and his personality?
No, and that's another thing I'm gonna change soon. So, what I would want it to do is realize that when it's texting Eli, it can text about the same as it texts Alex,
Right.
but not about the same as it texts Stacy Ross. So, I would like it to know that, and that's something I'm probably just gonna append to the system prompt. You are texting Eli Ferrara. He is in your grade, he is in the same program as you, he has similar interests, yada yada yada. Realistically, I wouldn't type out a bio for everyone. I would probably just make some fields like gender, age,
Or
relationship.
Maybe, if it's already in your contact, you put small rag just to get a snippet of how you talked before
I could,
and have that as part of the system prompt.
I could, but what I would need to do for that is run some small model to read some text
True.
and
vector
figure out, okay,
embedding.
what is, and it may not be able to do that. What would be easier is just, I have a script, I lock in for 20 minutes and answer for all of my contacts, like, they're my brother, they're this old. Actually, age I could get. I've got birthdays in most contacts. Yeah, there are a bunch of ways I could implement that. Alex, I don't know if I've ever mentioned aardvarks, so I don't really know.
Well, you clearly mentioned them at least once.
Abhijit, what do you?
What will the AI do, like your clone do, if you keep on repeating the same question? Like, if you ask, what's your favorite animal again,
Let's find out.
and like, keep on doing it.
He's trying to figure out the distribution of like
Will
answers
it
you'll
just,
give to the same
will
prompt.
it get irritated? Or like,
Will it get, so
kind of
it
emotion?
will realize that it's asking this, that I'm asking the same question. It does maintain context. Now, whether it will say anything about it, I don't know, but it will know.
Or like, what if you rephrase the question?
Oh, it would be an orca. All right, we're switching it up. I love learning about the way they hunt as a pod.
Wait, then ask it, what about aardvarks?
Do you want me to say it exactly like that?
Well,
Well, ask Hadley, because.
alright.
Yeah. What do you think?
Bro, what about the aardvarks?
Bro, what about the aardvarks? Wow, they're so cool too. It's tied for first with the ocelot. What about the orca?
I think this is where a larger
What
model
if you
would.
ask it about what it said?
Might be better.
Why have you responded to 3 different animals?
All right. Why have you responded with 3 different animals?
What is happening over here?
Sorry, Hadley. It was just hard to pick one. I think I'm gonna go with ocelot though because that's the best picture. Not sure what that means,
picture of
but I
life.
do know that it realized. What's more, it did know that it's talking to Hadley, and it used that in conversation.
I think I could notice this if I were texting.
Yes, you probably would, but it's getting to the point that, and as I tune this more, as I figure out more about it, it's to the point that would it pass the Turing test?
Probably not. I probably will.
Probably will. Eli?
Do you want to try asking us that cupcake recipe and explain why it does that?
Good one. So this is something Eli and I found out when we were testing it during not a class. Give me a cupcake recipe. Oh, it learned. So this is a pretty bad example. Oh, it's got a bunch of ingredients. Yes, please share it. Yeah, okay. So,
Did it memorize? Is that link valid?
unlikely. Most of the links it's given me have not worked.
Uh-huh.
Watch it work.
Yeah.
Yeah.
So top level domains it can do, like most of the websites it gives me exist, but specific pages on it don't generally exist. So when Eli asked it for a cupcake recipe, and it said in like lowercase, like, sure, I'll give you a cupcake recipe, and then it just pasted a cupcake recipe, like straight ChatGPT output. And the reason for that is because nobody in all of my however many texts, 300,000 texts, I think, has ever asked me for a cupcake recipe.
I can change that.
So it hasn't been fine-tuned. It doesn't know how I would respond in that scenario, so it falls back to the base model, the instruct model's output, which would be, sure, here's a cupcake recipe. So that's another issue, and that's something that a system prompt does have some leeway over. If I wasn't having the system prompt, then anything that didn't look like text, it would just act like normal ChatGPT-esque performance. Yes, Garth?
I mean, still maybe you'll be a better judge, but is the tone really that different in this case? Like,
From what?
From previously what you've asked it, like.
No, that's why
the
I'm
tone
intrigued.
has stayed the same.
The tone has stayed consistent. I'm now that I'm thinking about it, Eli and I may have been working with an older version. I think I may have retuned it since
Gotcha.
then.
Oh, yeah, because that same day and not another class period, you trained it with like more epochs.
Yeah.
And
No, I have only stuck to one epoch because I don't want it to
I
overfit.
saw
my
your
data set.
number went lower. It was like at 1.1 or whatever at the end.
My loss.
Your loss was lower. You trained
Because I don't remember. Oh, I switched.
it. You switched to 3.1. Oh, because remember you asked Karthik. So
Yes.
it's not class.
Yes.
Oh.
That's what it was.
What?
Oh, when you switch to chat.
Yes.
Yeah.
No, I switched to. I was accidentally downloading the wrong model
Oh yeah, I
and
remember.
then formatting it wrong. Yes, Ruby.
What if you asked it about like an upcoming event? Like, would it be able to like go into the future and say like, oh, like, I'm excited for that or something?
Good question. So right now, all it knows is my text. And if something has not been really frequently mentioned in my text, then it's not going to have that in its mind, and it's not going to be able to talk about it. It may hallucinate. If I asked it if it's excited for prom, it would be like, yes, I'm so excited for prom. But it maybe would think prom is in 2 days, maybe it would think it's in 3 years, and it would have no idea who I'm going with, what we're going to do, because that's not something that was in my text enough for me to know. Now, pop quiz, what's a way I could fix that? Correct, RAG. I could use both workflows. I could fine tune the model so that it texts like me. And then I could use a RAG workflow so that I could actually get information about what's going on. Integrate my Google Calendar. Integrate more recent text so that it's been fine tuned on how I text, but it could also read my recent text to know what's going on. Yes, Ruby?
So what if, like, let's say you're texting with Hadley and she brings up something about physics, but you never texted with Hadley about physics, you only texted with Eli about physics. Would it know to bring up that thing from your text with Eli, or would it not know what to say because you're texting with Hadley?
That is a great question. That's something that I need to experiment on more. That's a lot down to how the creator of the model has implemented their system prompt. So some models that you can download, they don't even have a system prompt. Like you just talk to them. Models that are more recent allow you to input a system prompt, which I don't know if you were here for that, but that's like you are a helpful AI assistant, or you are Ben Ross's personal assistant, or you are a digital clone of Ben Ross, that kind of thing. Like you will always answer concisely. Like those kind of things that it should know and understand before it starts talking. So how it worked on that would be based on how much it weighs the system prompt. So if it thinks above all else, what's most important here is that I'm talking to Hadley Miller, I'm not talking to Eli Ferrara, then it probably wouldn't bring in that external knowledge from a different conversation. But if the system prompt to it is just some more input, then it would probably bring some of that in, maybe not as strong. Maybe it would maintain texting styles that it had picked up from my conversation with Hadley more strongly, but it would probably still recognize some things that I had talked about with Eli. Yes, Karthik?
In your training data, does the data look like you said this, Hadley Miller said this, Eli said this? Like, is for every text the person's name associated with it?
Good question. So I'm not going to show the training data. I tried to find a nice little snippet, not happening. But the way I've split it up is, and you can actually kind of see in the way it responds. So it went through all my texts, and it split them into conversations. So everyone I've ever texted has at least one conversation in the data set. They have one conversation for every time, every unique time I've texted them, which I defined as if it's been more than 12 hours since a text, we're having a new conversation. Now, this is a horrible way to do it. Because some people I take days to respond to. Some people, if I haven't responded in 5 minutes, we're just gonna start talking about something else. It's an imperfect solution. The best way to do it would be to manually go through all 300,000 texts and decide, okay, here's a new conversation. But even then, it's imperfect because texts aren't really split up like that. It's not like, all right, goodbye now until the next text. But it's split up like that. And then I have /n for a new line whenever I send a new text. So the human in the shared GPT format is the person I'm texting. So if we were to encode this conversation, let's say, what it would start with is the human saying, what's your favorite animal? And then it would be GPT saying, LMAO, I love aardvarks, they're so funny and cute, /n to signify that this next bit I sent as a separate text after the first one. I was looking at pictures of them for like half an hour last night. I couldn't stop laughing at how funny they looked or whatever it said. And then it would keep going like that in turn so that it would understand the context. And then each conversation in the data set has an individual system prompt. So that would be, you are a digital clone of Ben Ross, you were talking to Hadley Miller.
Okay, so who is talking within the data set is determined
By the
each
system prompt.
within
Per conversation.
per conversation.
Yes.
And that's what it's trained on.
Yes.
Makes sense. Cool. So that's how it knows who's it's talking.
Yes,
Just-
exactly.
Just by you typing it in there
Mhm.
isn't gonna help if it never saw those names before.
Exactly.
That makes sense.
Eli?
What if you like try to do a group chat? You have like Hadley Miller and Eli Ferrara. Oh.
Was that what all of you were
Yeah.
gonna ask?
Like if you, I mean, would it work or would it try and interpret Hadley Miller and Eli Ferrara as one person with like 5 names, like first, middle, last names?
Is that still rolling?
It's still rolling.
Yeah.
Alright. Good question. You guys I like what you're thinking about here, and these are a lot of the same concerns that I've had with making it. So the way I have it set up right now, it just, I mean, I don't know what it's thinking, but I know that in the system prompt it says, you are texting Eli Ferrara and Hadley Miller. What it doesn't know is who of those are in the human responses in the data set. So it thinks it's getting some amalgamation of texts. It learns how I respond to those, but it doesn't realize that you said this, Hadley said this, now what do I say? Not yet, but that would be a fairly easy change.
That was awesome, guys. Round of applause. That was
Thank you all. Glad you could come.
thanks, man.
Of course.